If you go to our Algebra 1 Teams page and you look in the most current week's channel, you will see that, right, today's work, we're doing page 3 of week 8 problems, questions 1 through 5. We have one Khan Academy practice that I assigned you guys, and you have one video to watch as well. So just a note on yesterday, right? Yesterday I was absent, but I posted the work, right? Page 2 of week 8 problems, questions 9 through 12. And this, you could click here and it'll link you to a YouTube video where I explain these problems. Right? I also posted the same link right below where it says that I canceled the meeting, right? So below it says Thursday class is canceled. I have the YouTube video, so you could watch it. So that way you could get help with problems 9 through 12 on page 2 of week 8 problems. Right, but you could do that on your own time. And today we are going over page 3 of week 8 problems, questions 1 through 5. Right, so we're doing a whole new topic, right? So you could watch this video to help you with support in addition to the Khan Academy practice. Right, we could also scroll up to where it says page 3 examples. And we could read through these examples and to get a preview of what we're going to be working on, right? So we're solving one variable inequalities. They have the examples here and here, right? And then from the problems of these, we're just doing 1 through 5 today, right? So right? So like the ones, the posts of page 3 problems that I posted, right, will look like this. So it's only questions 1 through 5. So let's focus on those questions, right? And this is good news. Solving inequalities is a little bit of a break for you guys, right? And that we were doing some tricky stuff before. And good news about solving inequalities is that it's pretty much the same thing as solving equations. So just a little bit of terminology, right? This means greater than, this means less than, this means greater than or equal to, this means less than or equal to. So when we are doing these problems, right, we solve them just like how we solve normal equations. The only difference is if you multiply or divide an equation by a negative, then you reverse the inequality direction, right? So an example of that, right, say you have negative 4x equals 12, right? To solve this equation, you're going to have to divide by negative 4 on both sides. So when we divide by negative 4 on both sides, right, it's a less than symbol, right? It's pointing to the left. Now it's a greater than symbol. It's pointing to the right, right? These cancel out, and you get x is greater than negative 3. A non-example, right, would be, say, a non-example would be 5x is less than negative 25. Right, so for this one, we would divide by 5 on both sides. Right, since we're dividing by 5, a positive number, so we're not changing the direction. Right here, we divided by a negative number, so we changed the direction. But here, even though this side is negative, the number that we're dividing by is positive. So the direction does not change. We just get, right, x is less than negative 5. So for the problems that we're going to be doing, right, start off with number 1. Right, so we might remember in order to solve this problem, right, what we're going to do is we just add 1 to both sides. So we're going to say plus 1, right? Because the first thing that we got to do is we got to separate the x's and the 1's. So we're going to move this to the other side, right? Cancel that out. So then we just get 4x is greater than or equal to 8. So now we're going to say, right, we divide both sides by 4, right? We're dividing both sides by a positive, so it's going to stay the same, right? The 4's cancel out, and we get x is greater than or equal to 2. So now to plot this, just to get a better understanding of what we mean here, right, what we got to do is, first off, since it is a greater than or equal to, we use a dot, right, a filled in dot. If there was no line underneath, it was just strictly greater than or strictly less than, then we'd use an open dot, meaning not filled in. Right, so greater than, right, x is greater than 2, right? We know 3 is greater than 2, we know 4 is greater than 2, right? So we know we're going to go in this direction. If you're confused about like which one is greater than, which one is less than, then just like pick the numbers at the end, or like pick a big number, like negative 100 for the left, positive 100 for the right. But for this case, we'll just use negative 10 and 10, right? So we're replacing the x with negative 10. We're replacing the x with 10. Right? Which one of these is true? Is 10 greater than 2? Or is negative 10 greater than 2? Right? We know this one is true, right? This one is false. So we're going to make our line go to the right. Okay, so now we're going to do problem 2. So the first thing to do for problem 2 is we got to distribute, right? When we have a number outside of parentheses, right, we got to multiply them both. So it'll be 2 times x minus 2 times 5, or 2x minus 10, right, is less than or equal to 8. So now we got to separate the x's and the 1's, so we're going to add 10 to both sides. So we're going to say plus 10 plus 10. Right, and so that way these guys cancel out. So we get 2x is less than or equal to 18. Right, now we got to divide both sides by 2. Right, to make these guys cancel out. And remember, we divided by positive 2, so we're not going to change the direction. And then we just get x is less than or equal to 9, because 18 divided by 2 is 9. So we're going to make our filled in dot at 9. And then let's test the two ends, right? We're going to replace x with negative 10 and 10. Right, so is negative 10 less than or equal to 9? Or is 10 less than or equal to 9? And once again, if you're confused about, right, if you're confused about the terminology here, just remember that, like, right, it should always be the bigger number pointing to the smaller number. So to make these signs true, right, the bigger number is not pointing to the smaller number. But here, the bigger number is pointing to the smaller number. Right, so we know it's on the left. We know it's not on the right, so we know that this line goes to the left. So we make our dot here, and we just draw a line to the left with an arrow, saying that x could be any of these numbers, right? To make it true. Because 8 is less than 9, 7 is less than 9, 6 is less than 9, and so on and so forth. So for the next problem, we have so we have 3 minus 2x is less than x plus 6. So let's remember, with these problems, we got to move the x's to one side and the 1's to the other. So let's start off by saying let's move the x to this side. Right, so we're going to say, right, minus x to make this cancel out. And since we're making these x's cancel out, we want to make these 3's cancel out. Because remember, we want to cancel something out on each side. Right, so something's canceled out on the right, something's canceled out on the left. So now we will have effectively separated the x's and the 1's. Right, negative 2x with another negative x gives us negative 3x. And 6 minus 3 is 3. So now we got to divide both sides by negative 3. And since we're dividing by negative 3, right, we're switching the direction of the inequality. Right, the inequality was pointing to the left, now it's pointing to the right. The negative 3's cancel out, and we get x is greater than negative 1. So now we're going to make an open dot at negative 1. Right, because this is not or equal to. We're saying it could be really close to negative 1, but it can't exactly be negative 1, which is why we use the open dot. So now we could test, this 2 sides, right? So which of these is true? Is negative 10 bigger than negative 1? No. But is 10 bigger than negative 1? Yes. Okay, so we know that our arrow is going to go to the right here, because this is true and this is not. So now you guys got to do problems 4 and 5. Okay. And then remember that you also have the Khan Academy work. And with that, you are done. Hopefully, and watch the video for yesterday if you haven't already.